$200 behind, I would take my last $200 and work on that, you know. And I'd solve that problem, but then the rent would be due and the electric bills, and I couldn't pay them. So the auctioneers would be sent in to auction off everything in my lab. So I had to sit back. I couldn't adjust to say, well, I got to sit down, $25 for rent, $200 for this, for a machine. I couldn't do that because I was very near the answers. And the type of problems I worked on were outside of the frame of reference of most science. In the fluorescent tube, you have high voltage moving along, you have a transformer that generates it, and you put a phosphor material that glows. But the tube is round, and the phosphor on the back side does nothing. There's only the phosphor on the front side. So I want to extrude the tube so it's elliptical. So you have more light surface in an elliptical tube. Then I wanted to mirror back the back of the tube. Instead of putting a big reflector outside there, put the mirror inside the tube. So I didn't have the money to make that tube. Then I said, what the hell are you making a tube for? Why don't you work on a flat sheet of glass that phosphors, that glows? So make glass that's electrically conductive. Well, how do you make non-conductive electrically conductive? By putting metallic particles in the glass and phosphors. What would happen? The electric current would flow through the gas, animate the phosphors. So you had a flat sheet. You don't want a lamp. A lamp is only giving light on one side. I wanted the whole surface to glow.
Over time, Jacques' ideas about the future became more well-organized and focused. Gradually, he began to combine his technological expertise with what he had learned about human behavior, sociology, and social structure.
I spent so many years improving area by area. I said, look, the whole society is aberrated, the way we do things. Why not redesign society? It'd be easier than making all these thousands of products.
So you really decided to redesign the culture?
Because I couldn't patchwork didn't work. It wasn't sufficient. So they thought I was a communist. You know, after all, the guy wanted to redesign society. What else?
What is socio-cyberneering?
Socio-cyberneering is a new organization, and it represents the application of the most sophisticated forms of science and technology toward problem solving so that we can reclaim the environment which we loused up over the years and to build a way of life worthy of man, to humanize society, to break away from the artificiality, the regimentation that dominates our society today. Our society seems torn apart and pulled in many directions. Socio-cyberneering is an approach at the restructuring of society in humanistic terms.
Humanistic terms, yes.
The mission of socio-cyberneering was to build a residential research center, developing and demonstrating new technologies and innovative social concepts within a community setting. On a barren scrap of land in central Florida, Jacques and a few friends began to build what is now known as the Venus Project, named after the tiny nearby village of Venus, Florida. Occupying some 25 acres, 10 buildings have been constructed. Each utilizes both design, construction, and lifestyle concepts integral to developing a working model of harmony and high productivity, integrating both nature and advanced technology. Jacques' objective of conducting a complete reassessment and redesign of our entire culture remains the central focus of his work. With the Venus Project, he has created an environment conducive to creativity and innovation.
When people come here, they're amazed to hear that this was just a flat tomato patch. We've dug out streams and ponds and planted hundreds of palm trees and trees. And we built this land to show what the outskirts of the city would be like. We have many buildings here, but you can't see one building when you're in another. We really wanted to show how high tech and nature could coexist within this environment.
Jacques and Roxanne have been living on the property and building the Venus Project since the late 1970s. The entire time has been a constant process of developing and implementing new ideas. Jacques begins with a drawing, then produces a scale model, and then videotapes his models in order to demonstrate his concepts for the future. Although Venus, Florida is relatively isolated, visitors often make the journey to see the Venus Project and to meet Jacques.
Joan?
I'm Margaret.
Hi, Margaret. I'm not going to remember your names, but I'm John. Hi, how are you? Good to see you. How are you? We haven't met. Have a seat, and then we'll go on with what this is about. Is everybody here? So, there was a time when most people believed that the decisions of the majority was very close to reality. But there was also a time when the majority of people believed the earth was flat. And if you ask me whether they were sincere, they said, of course, you can see it's flat. So they'd break a sincerity meter. But it isn't sincerity that the world needs. It needs the intelligent management of the earth's resources. This is what we don't have. The major contribution the Future by Design would like to provide is a method of coping with problems. Now, you're brought up to believe, I believe this, that everyone should have a right to their own opinion. Is that the way you were brought up?
Yes, sir.
Okay. When you got everybody going around giving their opinion, I'll tell you what's wrong with Jim. See, they've got all kinds of opinions. But when engineers talk to each other, they don't say, believe me. They say, see this new metal? It can hold up 4,000 pounds per square inch. He puts it in a machine and pulls it apart. He says, you're right. So I would say the majority of the people of the world today are unsane, not insane. Unsane meaning having been exposed to methods of evaluation that are long rendered obsolete. Our language in the future will change to a saner language where we have no argument in it. They say, well, can there be such a language? There is. When engineers talk to each other, it's not subject to interpretation. They use math, they use descriptive systems. If I interpreted what another engineer said in the way I think he meant it, you couldn't build bridges, you couldn't build dams, you couldn't build power transmission lines. The language has to have meaning. That's why when a doctor writes a prescription, if he prints it, it's the same all over the world. So the world I'm talking about is different.
There aren't too many people that have seen everything that he's gone through in the past and come out of it with a certain direction. And the interesting thing is, too, that he's not a philosopher that talks about how the world should be, his point of view. He's a technician that understands how it can be built and has worked with people and understands what it takes to change them and understands what it was that made them that way. So it's really based on hands-on learning and not reading something in a book. He went through the experiences himself and came out with the conclusions he did because it was based on actually learning experience and experiments.
When an engineer has an idea, he talks to the computer about his idea. While they're talking about it, the integrated computerized system will take the elements that they're speaking about, convert the language into imagery, and the image will turn and be exposed to all of the people watching that exhibit and presentation. They will question the presentation, but the image system will answer the questions. How the buildings are fabricated, how water is supplied, how it handles earthquakes, or any other question. Instead of people sitting around asking individual questions, the answers are demonstrated inside of what appears to be a transparent dome. So ideas